All right, let's get right into it. We're going to explore something pretty fundamental today. How exactly does your brain take this absolute storm of information hitting you every second and turn it into the stable, coherent reality you experience? It's like a constant process of weaving happening inside your head right now. So, to wrap our heads around this, let's start with a feeling we all know. Why does scrolling through some fast-paced, jump-cut video feed feel so jarring and chaotic, while getting completely lost in a good book feels so immersive and whole? I mean, at the end of the day, they're both just streams of information, right? So what is the real difference inside our brains? Well, on the one hand, you've got an experience that's totally fragmented. It's volatile, it's driven by these constantly changing little details, what we're going to call figures. And on the other hand, you have something that feels integrated and stable. It's an experience that actually lets your brain build up a rich context, or what we'll call the ground. And the key to all this, it isn't what you're seeing, but what your brain is actually allowed to do with that information. To really understand that, we have to kind of throw out the old idea of the brain as just a collection of separate boxes. You know, a vision box here, a language box there. It turns out neuroscience is showing us it's much more like a continuous map, a single landscape that has this one fundamental organizing principle.
And that principle is called the principal gradient. Just think of it like a journey the information takes. It starts at the outer edges of your brain, the parts that handle raw sensation, and then it travels inward, all the way to the deep inner core. And that's where all that raw sensation gets woven into the actual fabric of meaning.
So out here, on what you could call the outer rim, the sensory cortex at the back and sides of your head, your brain is just processing the immediate, raw data. The flash of light from a screen, the sound of a single syllable, the feeling of a touch. It's all happening right there, in the moment. But as we move inward along that gradient, we get to the inner core, these midline and frontal regions. And here, the brain's job completely changes. It's not just reacting anymore, it's integrating. It's taking all those sensory fragments and piecing them together into a coherent scene, or a memory, or even an abstract thought. This is literally where context is born.
And what's really fascinating here is that this spatial map, from the outside in, is also a map of time. See, different parts of the brain are working on completely different timescales.
So the outer rim, that's operating in milliseconds. It's catching every single visual cut, every syllable. But as you move inward, the window of time it's looking at gets longer. The next region's in work over seconds, binding those syllables into a full word, or those frames into a complete action. And then, deep in the core, those midline regions are integrating information over minutes at a time, tracking entire storylines and scenes. And this perfectly illustrates these old Gestalt ideas of figure and ground. The fast outer parts of the brain, they're tuned to the figure, the sharp, sudden details that pop out. The slow inner regions, they're responsible for building the ground, the stable, meaningful context of the whole situation. Okay, so here's the crucial point. When media is just constantly hammering us with rapid-fire cuts and dings and notifications, it is relentlessly activating the figure side of our brain. It keeps jerking our attention to a new detail before those slower, deeper parts ever get a chance to build a stable ground of understanding. Okay, so we've got this processing structure, this gradient from raw sensation to deep context. But what about the actual content? How are concepts like people or tools or places organized within that structure? The answer is pretty incredible. It lies in what scientists call semantic maps. Now, these aren't little spots in the brain for each word. No, it's more like these huge, orderly landscapes where related concepts are clustered near each other, spread all across the cortex. For example, certain areas on the side of your head tend to respond more to things like people or animals. Other regions are tuned more for places or tools. But here's the most mind-blowing part. The general layout of this internal atlas, this map of meaning, is remarkably similar from one person to the next. It's like we're all working from a shared blueprint.
And this shared blueprint, this is what leads us to a discovery that is so profound, it's almost hard to believe. It's about how we process stories and how our brains can achieve this pure, abstract level of understanding.
So let me just ask you this. When it comes down to actually understanding the meaning of a story, does your brain really care if that story came in through your eyes or through your ears? Think about it. When you read a story, the visual cortex at the back of your head starts decoding the letters. That information then flows forward, and it activates this really complex but very specific pattern across all those semantic maps we were just talking about. The pattern is the story's meaning.
Now, here's the big reveal. When you listen to that exact same story,
Sure, your auditory cortex processes the sounds first, but once that information gets past the initial sensory gate, it activates the very same pattern across your semantic maps. To your brain, the meaning is represented identically.
And this isn't just a theory. Researchers found the brain activity was so similar that a computer model trained only on data from people listening to a story could accurately predict the brain activity of people reading that same story. It's like there's a shared code for meaning in the brain, totally independent of which sense it came from.
So, let's bring this all together. We have a brain that's built on a gradient, from simple sensation to complex meaning. It's got these shared maps that process that meaning no matter where it comes from. What does all this actually mean for us in our day-to-day lives? How can we use this knowledge?
Well, it takes us right back to where we started. Some media designs, the constant flicker, the notifications, the jump cuts, they are basically engineered to keep resetting the figure and keep your brain in a purely reactive state. But others, the ones with pauses, with coherent scenes, they allow that neural ground to form, and they create stability. One is designed to pull your strings, the other helps you reweave your own mental fabric.
The danger here is that a constant diet of this fragmented content can basically wear grooves in our shared mental maps, creating these overused, narrow highways of thought. It makes it easier for our collective strings to get pulled. But, and this is so important, that very same system, its flexibility, its shared nature, that's also our route to repair and strengthen it.
So how do we do that? We do it by choosing to engage with things that actually respect our brain's need for time. Things like long-form reading or deep listening. They're like cognitive weight training. They engage the full depth of that principal gradient and our semantic maps, letting us build the complex, stable, and layered understanding that our brains were literally designed for.
Look, at the end of the day, the way our brains are built gives the media we consume immense power to shape our perception. But that same architecture gives us the power to choose. The patterns of our mind are not set in stone. So the final question really is for you. Now that you've had a glimpse of how the loom works, how will you choose to weave your own experience?